In this video, we're going to continue our discussion about simplifying expressions that involve square roots. So numerical expression involving a square root can be simplified if the radicand, that's the value inside the square root, has a perfect square factor other than 1. The product rule for radicals can be used to factor the square root. So if I have the square root of a times b, so two numbers multiplied together, I can split that up into two separate square roots. That equals the square root of a times the square root of b. So for example, if I had the square root of 300, I know 100 goes into 300 evenly. 100 times 3 is 300. And that's helpful because 100 is a perfect square. So I can rewrite 300 as the square root of 100 times the square root of 3. And then the square root of 100 is 10, so we have 10 times the square root of 3. So essentially, because 100 is a factor of 300, we were able to factor away a square root of 100, or 10, outside the radical. And then that is simplifying the radical when we factor away what we call the perfect square factor of the radicand and bring it outside the radical. The easiest way generally to do that is to make a factor tree for the radicand. So let's say we were trying to simplify the square root of 12. So I'm going to make a factor tree for 12. So I know 12 is 2 times 6, but I can keep going there. 2 won't break down any further because it's a prime number, but 6 will. I can make a tree under 6, and that's 2 times 3. So now we have all prime numbers. So I could rewrite the square root of 12 as the square root of 2 times 2 times 3. Now, a perfect square is represented by a group of 2 of the same factor. So notice we have a perfect square there. 2 times 2 represents a perfect square. So I'm going to continue on with that. And 2 times 2 is 4. So I'm going to split away a factor of square root of 4. And then leave the square root of 3. And then because 4 is 2 times 2, the square root of 4 is just 2, so I'm left with 2 times the square root of 3. And once we have factored out our perfect square, then our expression is simplified. So the square root of 12 equals 2 times the square root of 3. Well, let's look at another example. This time we're given the square root of 36. So 36, let's see, we could do 4 times 9. And then 4 will break down into 2 times 2. 9 into 3 times 3. And then we've broken that down. So the square root of 36 equals the square root of 2 times 2 times 3 times 3. 2 times 2, that's a perfect square. But 3 times 3 is also a perfect square. So notice there's nothing I didn't circle. 36 is completely made up of perfect squares. Hopefully you notice that at this stage here when I split it up into 4 times 9, because 4 and 9 are both perfect squares. The square root of 4 times the square root of 9. Well, square root of 4 is 2. Square root of 9 is 3. So we get 6. And hopefully that's something you knew to start out with. 36 is 6 times 6. So it's a perfect square. So if your number is completely made up of perfect squares when you break it down into a product of prime numbers with your factor tree, then you have a perfect square there, and there's not going to be anything left underneath the radical. Now notice that was different to the first example. That 3 there was left inside the radical. It was not a perfect square. So sometimes we'll have leftover, sometimes we won't. And when you don't have anything left over inside the radical, that means the number you were dealing with is a perfect square. But let's continue on there. You may want to pause the video and see if you can do the next couple of examples on your own. Alright, I'm going to assume we've done that if we want to, so let's go through these last few examples. So we have the square root of 42, so I'm going to start out with my factor tree. So 42, I could go 6 times 7, and then 6 breaks down into 2 times 3, and then the 7 comes down. So we can rewrite the square root of 42 as the square root of 2 times 3 times 7. Well, it takes a group of 2 of the same factor to make a perfect square, and I don't see any groups of 2 of the same, so there are no perfect square factors. And what that means is the square root of 42 was already simplified as it is. So the square root of 42 will not simplify any further. So if you were asked to simplify the square root of 42, your answer would just be square root of 42. It's already simplified. Alright, now let's look at 3 times the square root of 18. So let's see if we can break down 18. So 18 is 2 times 9. 2 will come down, and then 9 is 3 times 3. So we can rewrite 3 times the square root of 18 as 3 times the square root of 2 times 3 times 3. And in this case, we do have a perfect square factor in there. The 2 factors of 3 make up a perfect square. So there is a factor of 9 inside there. So we have 3 times, let's factor away our perfect square, so times the square root of 9. And then times our leftover square root of 2. So our perfect square there, we've got the square root of 9. Let's go ahead and take that. The square root of 9 is 3. So we've got 3 times the square root of 2. And 3 times 3 is 9. So we have 9 times the square root of 2. And now that's completely simplified. Now 2 does have a perfect square factor, but its perfect square factor is 1. Anytime the perfect square factor is just a 1, we don't worry about it. Notice in our factor trees and anything, we're not breaking down the numbers any further once we get to prime numbers there, so we don't make 2 times 1. We don't really care about factors of 1, but 1 is a perfect square. Square root of 1 is equal to 1. Alright, so last 2 there. Continue on. This is an incredibly important concept there, so we want to make sure we have it down. So this time we have 5 times the square root of 48. So 48, I can break that down into 6 times 8. And then 6 will break down into 2 times 3. 8 will break down into 2 times 4. But I can keep going. The 2's and the 3's won't break down any further, but 4 breaks down into 2 times 2. So now let's rewrite this as 5 times the square root of, well, we've got 1, 2, 3, 4 factors of 2, so 2 times 2 times 2 times 2, and then 1 lone factor of 3, so times 3. So let's see, do we have any perfect square factors there? So a group of 2 of the same represents a perfect square. So I've got a group of 2 2's. there's a perfect square, and then another group of 2 2's. So there's another perfect square. So let's factor both of those away. So 2 times 2 is 4. So there's a square root of 4 to factor away. And then another square root of 4. And then my leftover there would be the square root of 3. So we have 5 times, and then square root of 4 is 2. Another square root of 4 is 2. And then that's times the square root of 3, our leftover. And by leftover, I mean it's staying inside the square root. So multiply out these numbers there. 5 times 2 is 10, times 2 is 20. So we have a 20 outside the radical, and then it's times the square root of 3. So 20 times the square root of 3 would be the simplified version of the original problem there, 5 times the square root of 48. So last example here for this video, let's go ahead and simplify this. So we've got 6 times the square root of 150. So let's see if we can make a factor tree for 150. Well, it ends in a 0, so 10 is going to go into it. Let's do 10 times 15 to start. And then 10 will break down into 2 times 5, and 15 will break down into 3 times 5. So let's see, we've got 6 times the square root of 150. So we can write that as 6 times the square root of, well, we've got a factor of 2, times a factor of 3, and then 2 factors of 5. So 150 is equal to 2 times 3 times 5 times 5. And we do have a perfect square in there, so we've got a group of 2 5's there, so that would be a perfect square. So we're going to factor that away. So we have 6 times the square root of 5 times 5, which is 25, times our leftover there is 2 times 3, or 6. So now we want to take the square root of our perfect square. So that's 6 times, well, the square root of 25 is 5, and then times our leftover there, the square root of 6. Go ahead and multiply 6 times 5 is 30, and then bring down your leftover square root of 6. So 6 times the square root of 150 will simplify into 30 times the square root of 6. Alright, so that's the end of this video. In the last video in this series, we will talk about complex numbers.